Okay, so 7 and 8, problems 7 and 8 are very similar to 3 and 4. We're just adding in the aspect of simplifying the radicals like we did in 5 and 6. So in problem number 7, we have negative 6x squared equals negative 246. Remember, our goal for all of these problems is to get the variable by itself. So we want to get x squared completely by itself, but we are currently multiplying x squared by negative 6. So how do we undo multiplying? What's the opposite of multiplying? Divide. So we're going to divide negative 246 by negative 6. And these negative 6's over here cancel out. So we end up with x squared equals, what is a negative divided by a negative? A positive. Hopefully we're getting more comfortable with our negatives and our positives here, and now that we're dealing with so many of them. So this is going to be a positive number. 246 divided by 6. I don't expect you to do that in your head, but you should get 41 as your answer. So x squared equals 41. Now we're still trying to get the x completely by itself. So to get rid of the squared part, we are going to take the square root. Now what do you need to remember in front of the square root of 41? I'm even going to give myself some more space here. What do you need to remember in front of the square root of 41? That plus or minus sign, right? You wrote in the square root sign, so you need to write in the plus or minus, because a positive number times a positive number gives you a positive, and a negative number times a negative number gets you a positive. So on the left-hand side, this square root and the squared cancel out. You end up with x equals. Now let's think about 41. Can you think of numbers that multiply together to get 41? Now I know 41 is not a perfect square, but let's think of any number that multiplies to get us 41. So 1 times 41, that one's a given, but that doesn't really simplify anything for us. 2 times nothing because it's odd. 3 times nothing because that would give us either 39 or 42. 4 times nothing because that would give us 41. 5 times nothing. 6 times nothing. 7 times nothing. I'm seeing a pattern here. There is no number. We can't simplify 41. 41 is a prime number. There's nothing that multiplies to get 41 besides 1 times 41. So, because it's a prime number, this is just our answer, plus or minus the square root of 41. If you don't like writing it like that, you can write it like we have been writing all the other problems. X equals the square root of 41 and the negative square root of 41. One thing I want you to be aware of, when you notice that I'm writing my answers, do you see how I'm writing my signs out front of my square root? You want to make sure you're writing your signs out front, because remember back to problem number 4, if you take the square root of a negative number, it's no solution because there's no number that multiplies by itself to get us a negative. So when you're giving a negative answer, make sure you're writing the negative out front of the radical. Okay, moving on to problem number 8. We want to get the variable completely by itself. So how do we get k squared completely by itself? We're currently subtracting 5 from it. What's the opposite of subtracting 5? Adding 5. So let's go ahead and add 5 to both sides. We get k squared equals 6. But we don't want k squared, we just want k. Hopefully you're getting the idea here. We're always taking the square root in this section, so let's take the square root of both sides. But wait. You're the one who just wrote that square root, so what do you need to write? Plus or minus out front. Okay, so let's think about the square root of 6. Can we simplify this down into any perfect squares? I know 2 times 3 is 6. But are either of those perfect squares? No, they are not, right? So just like number 7, our answer is either k equals plus or minus the square root of 6, or if you don't like writing it like that, k equals square root of 6 and negative square root of 6. So when you cannot simplify your radical, you just leave it as is. When you can't simplify a radical, that means you can't think of any perfect squares that multiply together to get you that number.